Okay, hello class, weekly update 10, I believe. Okay, lots of stuff, so I'm gonna talk fast. A couple announcements first off. Withdrawal date is March 22nd, so just a few days. There are a few of you that I'm concerned about, so some people getting behind and I'm worried about for the final. So two people in particular, and I've contacted you, but if you are considering, you could shoot me an email too if you just want to chat about it, what your options are. Okay, then I got a few folks. Kelly, thank you for putting, like, whenever you guys put notes in those submissions, that's helpful. And yeah, so Kelly was worried that some things got late. She had some tech issues this time to submitting her work and had to get up the next morning and try again. Totally fine. And if that happens occasionally, you're not going to get penalized. But I just wanted to let everyone know, I think I've mentioned this once, but just a reminder that I purposely don't close those drop boxes. So some other classes, professors, like, that's a hard deadline. For us, you need it in there to get full credit, but it's open till the rest of the semester. And then someone else, I think it was Dana May, was talking about wanting to resubmit work. Happy to have you do that anytime throughout the class. If there's something you look back and you're like, oh, actually now chapter 3 in book 3, I totally get that. At this point, well, if that's the case, we welcome you to resubmit and we'll override those grades. The only key to that is you have to email Chloe and let her know, like, hey, I already did, you know, the first half of chapter 3 assignment, but I would like you to regrade it. So this is always about, we're trying to get to mastery by that final exam. That final exam is timed, solo, and you have to show your work. So we're using all these tools to get ready for that scenario at the end, and to understand and master the material. So you have lifelines to your group members, you have the challenge problems that help you understand particular concepts, you have these weekly low stakes deadlines, but all preparing for that mastery at the end. Okay. All right, then let's jump to the assignment. So in the samples and examples section, you guys can check that out as usual, but I've put in some shout outs. Like, I think actually this week, the team shout out goes to Team PBS, Patrick Puckhaber, Liam, and Cameron. So some folks this week, though, on the calculations that I put in there was Cameron, actually the whole team there, Cameron, Grant, Cameron, Liam, and Patrick, and then also Grant and Griffin. Really nice displays as usual. Dana, May, and Clarissa. Just, if you look through those, you'll see all of the problems of every part was worked. Then the activities, I really liked Aaron and Liam's discussion of some of the activities and what their thought process, why they did what they did. And in particular, in some of those assignments, like for instance, Liam and Patrick both mentioned they're taking linear algebra or have taken it, and how you could think about some of these calculations that we're doing in terms of linear algebra, and they're really just REF forms on a matrix, so row reduced echelon form. That was really neat to see that you're making those connections to other classes. That's exactly what we're going for here. Liam had a really nice discussion too. So many of you did the search engine one, and he thought about this for a while and said, okay, so they're all in the non-negative octant because we're 0, 1, or 0 for the, or 0 versus like 4 times this word was used and 7 times that one was used. So you can imagine those all shooting out. If you have a corner, your corner desktop system, they'd be shooting out into your room. But he was wondering about negation. And that was really insightful, Liam, because that is a issue actually to this day. How do you handle things like not or use negation? Like the word non-differentiable, or it was not used. And so there still isn't, like, again, that's an open question. There's still not a great answer for those. Sometimes people have thought about using negative in front of those. Some people take the not and the word as their own term. So lots of things are being done to handle negations, but they're an issue. Okay, and then the personality match, most folks did that one too. That was interesting to see. Grace, thank you. She said, I don't maybe care about those 4 people, but here's other people I care about. And she went and got their personality vectors or estimated those herself, and to see who she was closest with. But most people, the general consensus was that if you were making a dating app, you want to do orthogonal vectors. So that was like Christy, Griffin, Mac, Olivia, Dana Mae, Aaron, Cameron thought maybe that would be the best match. And then there are a few folks that thought opposites. Thomas and Grace mentioned that. And then just a few folks also thought the same direction would help. So they'd rather have someone compatible. Clarissa, Savannah, and Grant. And then again, I put Erin's in there because I liked her discussion of the thumb and finger cross product. So we have one of those U cross V points up and one of them V cross U points down. So I noticed that was a little issue on the quiz. Keegan, thank you for emailing about that, that we have these two vectors, but they point in opposite directions. So if one has certain coordinates, the other one has the negation of those, so the negative coordinates would be the V cross U. But Erin really had a really nice discussion about like, if the vector is this completely like that, then those two are orthogonal, and the cross product would be orthogonal to those as well. Actually would just be like a skewed version of the I, J, and K, right? Because they're all orthogonal. This would be an acute angle, and then I can't make mine go past 90, but maybe some people can. That would be a greater than 90-degree angle, but it still doesn't affect what happens with the cross product being orthogonal to those two. Those two create a plane, and then this one comes in. Let's see, what else? Calculations. Well, Ethereal looked like he went through all the problems, so he probably got them all down. Although his work is usually sparser than other folks. So I put, again, I think I put folks that tend to like step by step. We have some, like Cameron's very clean as a math educator, clean, clear, step by step. Griffin's and Grant's are always nice. Overall, though, it looked like nice job. Keegan had a really visual grasp of the vectors that I liked in hers. Christy included some 3D plot images that helped. In general, though, the only issue it seemed came down to number 6 on page 41. That was where you actually had two vectors in the XY plane. Let me get this right, draw this. Okay, I'm going to draw on this little whiteboard here because my husband, love this guy, is that's going to be, it's actually is a Murphy bed, pops up, and on the back of it is the whiteboard, so I'll actually have better lighting and better setup, but it's still being worked on right now. He's taping it in. So I'm going to do it here. Hopefully this will work. In the XY plane, we have these two. This was number 6 on page 41. We have y equals x squared, the parabola, and then the square root function. They intersect at a point of intersection, no problem getting that. That's all Calc 1 stuff at the point 1, 1. And the question was about the angle of intersection between these two curves. Well, they're curves, so we know how to get angles of intersection between lines or vectors, but what you could do is show their tangent vectors or tangent lines even. Those you know how to get from Calc 1. So put these two little dash lines in there. And those are the tangent lines. If you could get the vectors associated with them, then you could proceed to get the angle. And how do you get the vector associated with those? Well, you have a point and you know what the tangent line slope is, what it tells you to do to get to another point, right? So you can actually go from one point to another and therefore get the vector for the tangent line associated with x squared, get another vector, a tangent vector, and then therefore you've got two vectors. Go ahead and use the usual cosine formula to get the angle between them. A few folks emailed too. I think maybe if there's any errors with the cosine formula, it's because you are, maybe your calculator or tech tool is in radians. Make sure you switch that, convert to degrees at the end. Okay, I think that's all I need to say on that one. We will know how to do this a couple different ways. Like I think by the end of this chapter and then moving into chapter 2, we'll know how to actually compute tangent vectors for any plane curve or space curve. And we'll know a lot more about lines. So if you're worried like, hey, I'm having a little trouble with lines at this point, don't worry, you're gonna get a lot more on lines. So that one was a doozy. It was a little bit early to give you that. And so I was really kind of stretching you and testing you. And so I also loved, Griffin asked about that. Oh, by the way, Aaron, you were really, really close in getting it yourself. You're working out on your own. Griffin sent an email and I love just the way that he asked. He's like, I just want a hint on this. I don't want to know how to do it. So that idea of like being persistent and persevering. That actually is one of well-studied known traits to success in science, is that persistence and perseverance. It reminds me of my dog. She's gotten real. We got this game that we found, like if you hide little parts of the treat around the house and just let them hide it, it's like a little puzzle for their brain. She loves that. She just doesn't give up. And she'll just, even after she's gotten them more, she thinks there might be more. She keeps going. Okay. Okay, so I think that took care of all of the, oh, next one. So that was really good on the activities and calculations. Then your discussion, the other thing you had to do was your computer-based math with TJ. Listening to Conrad Wolfram. So, but I noticed only 7 people went in there and submitted this. At any point, again, you can go back, and if you had a rough week, you know, again, we've had midterms and crazy stuff, COVID and weather and all sorts of things. So if you want to go back and submit, we'd love that. We'd love to replace zeros. Zeros can really pull a grade down. You're like, I was doing so good in this class. Why did I end up with a, you know, a B plus? I thought I actually got an A. A lot of times that's because of a few zeros here and there. But the folks that submitted really interesting comments. Please go back and read your classmates' work. Clarissa talked about the only downside she could see was for folks that one of the things they're drawn to math is they like solving by hand. And so that's true. They'd have to like take it upon themselves to maybe do a little more of that. It's also interesting. Griffin had a nice take on that. He thought computer-based math, he used the word play a couple times. It gives you the ability to like play more with a problem and experiment and really just like play with what's going on with that particular problem, the concepts here, and trying to understand it. Patrick talked a little bit about the tactile loss. Like, again, if you're just doing all this coding all the time, typing on and letting the screen show you stuff, like, which is why I purposely design these books that there is tactile, but there's also a lot of that tactile things that you're doing. Like, I think the next edition, I just had an idea for the search engine problem where you make a little desk ornament, maybe like a pencil holder, you'd shove it into some foam. And so maybe this is my query vector, and then I have my other vectors, and it just represents like that one little visual there, and it's on your desk, and you can have it or not for perpetuity. It represents many things. You can even put that little Pac-Man cone from the first book around this query vector, right? You can visualize that cone. I got a really fat one. Bust a hole through this little Pac-Man cone. Oh yeah, there's this little eye on there. Bust a hole through that. So there is our query vector. I don't have enough hands and fingers here. Query vector coming out of the cone, and you could tighten that to not include, you know, maybe one's included now. You could make it tighter. But anyway, the point of that tactile loss I thought was really interesting, and that was why I'm trying to have a bit of a mix of that, where you do see some things, but you understand the limitations. That was something Patrick said. Like, I can't draw as good as, say, someone like Dana May. Like, so that's not going to get across the point, but I can see it 3D in space, but maybe I can't draw it. But then the tool comes and helps me in the tactile and draw some beautiful picture, and I can rotate it at all different angles. Let's see. Letherier also had some comments. Letheriel, Savannah, and Cameron all kind of hinted at this need, like, yes, we need this balance. And it was interesting because of those folks, I know for certain that like Cameron and Savannah are future math educators. So I thought that was interesting that they really took that we do need a balance between concepts and calculations. It can't be all computer-based math. But one thing I wanted to point out that Conrad Wolfram is the brother of Stephen Wolfram, who, and Stephen Wolfram is the founder of Wolfram Alpha, and Conrad's his brother, who also is affiliated with didn't invent it, but he's affiliated with the tool, which got me to the point of, I remember reading this once years ago, and that you should always question people's biases, even if you, like, I think Savannah was excited about this computer-based math. She said she showed it to some other folks, and this is something she's been talking about for a while, going on a rant about, you know, why are we doing this sort of antiquated way of teaching things? And this idea of questioning someone's biases, well, I mean, they have, the Wolfram brothers have a vested interest to push for computer-based math. They want to see more of that. They want universities teaching that way. They want more people using their product. I mean, it's a company employing hundreds of people, making money. And so that I don't think that takes anything away from his message. I also agree with it, and I'd like to see more of it. It's a bit controversial, but is gaining more momentum and a movement for computer-based math. I think that is the future. I think there's more people hanging on that are maybe a bit elitist about who can do it and not do it. You have to have a basic amount of calculation, and you have to. Oh, but that actually reminds me of a professor I had in graduate school. I remember you could ask him a question. And this was a class that was in optimization, so we could visualize things in like higher dimensional space and do polytopes. And so you're doing things with like R2 and R3, but many of these things extend, and you'll see more of that throughout the book. So we can talk about lines in R4, moving between higher dimensional points. You can't see any of them, but we can do them and do analysis. And anyway, people would ask a question. This guy, Elmore Peterson, that we called Elmo, but his eyes would just like roll back in his head. It was quiet for, it seemed like minutes, and then he'd come back and answer. He'd be like, yes or no, or 7, or whatever the answer was. But he always, that's how he did his calculations. Like he could do it. It took some time, but he wasn't speedy. And he was one too that learned, these old time mathematicians would only learn, like, who was it that was just talking about? Last week, one of you were talking about the fundamental theorem of calculus, how to check on a tech tool. Oh gosh, who was that? Anyway, Christy maybe? Using the differentiation and integration. Well, the old time mathematicians that I worked with when I was a grad student too, sometimes they only learned one way, say differentiation, and then they would just like reverse it to do the integration. So they only learned one set of rules. They wouldn't learn both differentiation and integration the way we usually teach it, and do the calculation on the spot. Anyway, I could go on tangents and tangents, but that's where I'll stop because it's already getting quite long. Okay. Oh, and then a few folks asked, yes, shoot me emails anytime with questions, and if you want to have an office hour, we can do that. This should be set up soon. But also a little bit of frustration. It seems like some folks have been going to the math lab, and maybe the people there are having a little trouble with these questions, because often, sometimes I put a questions like that one that we were just talking about. I mean, that's not a typical question you see in a book, and these challenge problems are not things you'd see in a book. So sometimes the math lab can help you, because remember, those folks usually learned in a much more traditional way of learning math. And the point of doing this is you don't have to get everything right at the moment. I mean, that's the hope with the books, but sometimes it takes time for things to sink in. You go back and you can get them. And also remember that, the people at the math lab, again, have learned in what was probably more traditional style. So it's going to take them a little bit of time to wrap their head around one of these tougher problems. And I want you to struggle with it sometimes, because we're trying, the whole goal too is to learn these things in such a way that I'm hoping you guys will go and invent new things. If we're just teaching rote and memorization and calculation, I think there's less of a chance of that. But if we're teaching concepts and like really stretching and extending ideas, then you guys might be the next amazing tech companies and founders and inventors and holding patents. That's the goal. So last comment is, this week you have a challenge problem. And I liked seeing a few folks have talked about, they start picking challenge problems because it's a concept they don't know. And they're like, hey, I didn't do very well with concept X this past chapter, so I'm going to try the challenge problem related to that. Or, it's interesting too, that using it as a way to get ready for the final exam. So again, maybe there's a concept you felt, I totally get Y, but I don't get X. Let's go after that one. Or just choosing it because you like the challenge of this one seemed really tough and I want to give it a shot. And as usual, go after as many upgrades as you want. You can work, again, with your entire team, part of your team, with someone else. So please, also the folks that did the discussion board before, like, you don't have to be limited to your team to branch out if you want to communicate and have lifelines to other folks in the class, or just trying to build community, more and more community as we go. All right, well, great job this time, and thank you for watching. Have fun this week.